Okay, this is the first part of the Unit 3 problems for review to prepare you for your quiz. So on the first one, it asks us to find the value of the derivative of the function f at 0 if f of x equals x to the 2/3 power plus 1, and then to sketch a graph of the function. So first thing we're going to do is to find the derivative. So they give me f of x, and I'm now looking for the derivative of f of x. We can just use power rule. So that's going to make that 2/3 x to the negative 1/3. Which would be, now we're going to plug 0 in. Because that's a negative 1/3, that's actually going to be on bottom the cube root of 0, which of course creates a problem for us. That makes this undefined because of the 0 on bottom. You can't divide by 0. So now we want to actually, it says for us to sketch a graph of the function. So if you're not sure what this looks like, let's just go ahead and plug it in our calculator, and then we can sketch a graph based on what the calculator says. So I'm going to plug it in. And actually what I had in is, what I already had in my calculator is actually pretty close to this. X to the 2/3 plus 1. So this is one of those, like, looks like a bird, like the birds you used to draw in elementary school. So it's like this. Then it says, use the graph to explain your analytical result for f prime of 0. So the derivative at 0 is undefined. Here's my 0 value. And the reason why it's undefined is that this is a cusp. So the graph has a cusp at x equals 0. So it is not differentiable. So now we're going to do this very similar problem on problem 2. It says to find the derivative at f of 2 if f of x equals the square root of 4 minus 2x. So we're going to find our derivative. So f prime of x. Let's see, I'm going to rewrite f of x as 4 minus 2x to the 1/2 power. So if I'm going to do this one, I'm going to use chain rule. So I'm going to say, y equals u to the 1/2 and u equals 4 minus 2x. So we're going to go dy du times du dx to get our derivative. So I'm going to do 1/2 the square root of u, because that would be u to the negative 1/2, times negative 2. That's dy du, du dx. My 2's would cancel and give me negative 1 over...
Announcement, can you please release all varsity football players at this time? Thank you.
Square root of 4 minus 2x. So there's my derivative at x. And now we have to plug 2 in. So I have f prime of 2, negative 1 over the square root of 4 minus 2 times negative 2. Oh, not negative 2, is it? It's just positive 2. Alright, so I get negative 1 over square root of 4 minus 4, and the same thing has happened, trying to divide by 0, so this is undefined again. So let's plug this one in our calculator and see what it looks like. We know what a square root function looks like. Let's just see what this specific square root function is. So I'm going to plug it in, 4 minus 2x. There it is. Looks like this. At 2 I have an end point. It goes the opposite direction. So it is not continuous at 2, which is why it is non-differentiable. This one was non-differentiable because it had a cusp. This one is non-differentiable because it's not continuous. So I'm going to write not continuous at x equals 2. Therefore, f of x is not differentiable. at x equals 2. All right, so next, it says find each of the indicated limits below. Hint, remember the definition and the alternate definition of a limit and what it tells us about the function. If you'll remember, when we first started all of this, we started with this ugly, nasty thing. The limit as h approaches 0 of f of x plus h minus f of x over h. That is the definition of a derivative. So when they give us this, what they mean is find the derivative of f of x. So you're always going to look right here. There was also an alternate limit definition that looked like this. The limit as x approaches some value, so I'm just going to put a, of f of x minus f of a over x minus a. These two things are essentially the same, just two ways of writing the same thing. In this case, we're always looking after the minus sign, and in this case, we're always looking in the front to figure out what our actual function is. And then we can just find the derivative. We don't actually have to use the long limit. Okay, so if that's the case, in this first one, that's our first limit definition. So we're looking after the minus sign. I can tell it's my first limit definition because on bottom I just have the single h. So I'm looking right here, and that's actually my function. So I'm just going to write over here on the side, f of x equals natural log of x, which means the derivative of that is 1 over x. And that's it. So same thing with problem B. This is the one with a single h on bottom, which means I'm looking after the minus sign for my function. So right here, this cube root function is what I'm looking for. Now remember, the minus is part of the equation, so the minus doesn't go with my function. So f of x is actually the cube root of 2x minus 3, which I'm going to write as 2x minus 3 to the 1/3 power. Chain rule that. Y equals u to the 1/3. U equals 2x minus 3. dy du times du dx. So dy du, 1/3 u to the negative 2/3, so I'm just going to go ahead and put it on bottom, times 2. So I get 2 over 3, the cube root of 2x minus 3 squared. That's my final answer. Let me make sure that you can see that. I'm going to zoom in on it so that you can see what I've got in here. Uncomplicate the picture there. So you see I did chain rule. Used chain rule to find my derivative, and I got 1 over 3 u to the 2/3 times 2. So that 2 is going to go on top, 2/3, and then I'm just rewriting this. 3 goes, remember, bottom of the crack, top outside the bracket, and then the u was from up here. And that's it. All right, looking on to C. Now this is that alternate definition. I know that because on bottom I don't have just a single term, but I have x minus something. So in this case, you're looking at the first piece, which is sine x. So my f of x, or my original function, is actually just sine x. So the derivative of that is cosine x. And this time they gave me a value to plug in. So I'm going to plug in pi over 2, cosine of pi over 2. When I just think about, you can use your little left hand trick if you want to. Pi over 2 is straight up. So if I go straight up, that means my x value is 0. So f prime of pi over 2 equals 0. All right, in D, we're back to just having the single h on bottom. So this is my actual function. They've already plugged in pi over 4. So let's see, I've got f of pi over 4 equals cosine pi over 4. So the derivative at pi over 4 is going to equal negative sine of pi over 4. Well, let's see. Left-hand trick. Pi over 4 is right in the middle. 2 on top, 2 on bottom. So it's going to be square root of 2 over 2, but it's negative. So I get f prime of pi over 4 equals negative square root 2 over 2. And that is it. Okay, so moving on to the last one at the bottom of the page. The equation of the normal line to the graph y equals e to the 2x. And then they said when dy dx is 2. Okay, so they have said dy dx equals 2. My derivative equals 2. That's what dy dx is. That's a notation for derivative. Well, let's go ahead and take the derivative of this function and see what we actually get. So y equals e to the 2x. Let's say, I'm going to use chain rule. I'm going to do, since they used y to start with, actually I'm just going to start with this. Y equals e to the u equals 2x, dy, du, du dx. That's going to be e to the u times 2x, times 2, sorry. So I get 2e, I'm going to plug u back in, and for u I had 2x. So this is what I get, 2e to the 2x. But they said dy dx was 2. Well, that's because they've obviously already plugged something in for x. So I need to solve this and see what it should be. Now, you can solve this probably in your head, because I need this e to go away, or to become 1. And anything to the 0 power is 1. So if I plug x equals 0 in there, that would make this equal 2. And that's exactly what I need. Now that's going to be important in a minute. Now, we all know that derivative is slope of a tangent line. I need the normal line. So if my slope of my tangent line is 2, my normal line slope, my perpendicular slope, is going to be negative 1/2. So that helps me a little bit because it narrows it down to 3 of the choices. Now here's where this x equals 0 part comes in. I need a point of tangency. I need a POT. And x equals 0. So I'm going to go back to my original function and plug in 0. And I get y equals 1. So my point of tangency is the point 0, 1. So y minus 1 equals negative 1/2 x. Now none of my answer choices are in point slope form, so I have to move the 1 to the other side. And I get y equals negative 1/2 x plus 1, which is A. All right, that was page 1 of the Unit 3 review. I will do a separate video for the next page.